data science is a vast field, right? It's a interdisciplinary field. It uses scientific processes, algorithms, and techniques in order to extract the right kind of insights that you can get from the structured and unstructured data currently, right? And the data science can be applied in any field out there. It can for problem solve technical problems, business problems, and all those. But my practice, is currently to solve the business problems, enterprise problems, using data analysis and data science and machine learning kind of techniques applied on that. In my opinion, by the definition of it, we are talking statistics and scientific applications and things like that, right? But there are a couple of things that really pulls me in when we say go back, right? One of them is, the empirical nature of our observations, whether it is people in the east or people in the west. They have the one use case of like looking at the sky and forming some empirical patterns, right? Based on that, they are able to form a science called astronomy, right? Astronomy, they are able to look at the patterns, and they know that this is a pattern that's going to repeat every 3 months or 6 months or whatever those things. And then they formed astronomy, and then based on that, they're able to do some time calculations, right? And in my opinion, that's probably the very first use case of data analysis or science or whatever you want to call it, right? um, and more fun application of the time calculations by is astrology, right? Like, hey, you go, if you go Linda Goodman based on sun signs, or who the moon sign from the east. All of them is based on the time of birth, and the certain things, planetary motions and things like that, right? So it is a fun side of it. But the good aspect of it, whether we believe the astrological outcomes or insights or not, it has kept the time calculation methodologies intact, right? So that's an application of, again, data science, empirical knowledge, data analysis, going way back probably 2-3 thousand years ago. That's, in my opinion, the very first application of that. The second one that I keep thinking of is North Star, right? Uh, you know, People, navies, merchants across the world, thousands of years ago, they traveled across the world, right? Like multiple seas and oceans and all that. For them, the one thing that kept them going is a North Star. And why is it so? Because among the different stars out there, North Star in the northern constellation, it is relatively the most stable star out there, right? So that is the star they could rely upon. That means the data coming from that movement is of highest quality for them, right? So the bedrock of any kind of analysis or data science or empirical analysis that we do is something that provides a highest data quality, and that was North Star for them. And that is indicative of, for a lot of people, it is indicative of integrity. So that's an another use case that I can go far back from a data science point of view.
That's really far back. I love that. That's excellent, though. The North Star, it's the highest data quality out there at the time, right? I mean,
Yeah.
it's something that you're saying data integrity, and we talk about it so often nowadays, but it's so cool to think about. Yeah, it's the same reasoning, right? It's the same why do they rely on the North Star is the same as why we rely on good data today. It's of the utmost quality, and it's something that we can rely upon. So I love the analogy. I think it's great.
That's cool. Thank you. um, and when we're talking about still in the past, but probably 100, 120 years ago, when the field of statistic was formalized, and then the immediate applications of statistic, probably was applied in the World War I, World War II time frame. World War I, World War II. I'll give you a funny example. FDR, he wanted us to produce 50,000 warplanes, right? By 1942, within 2 years, he wanted that. And then everybody were like, will we be able to do it? Do we have the production lines to do that? You know, and then what happened was, the other side, the Germans wanted to know if we truly will be able to get 50,000 planes out of the door or not. So they did some data collection, and their historians and statisticians come together, and they said we probably will be able to be within 40% of it, right? So that means we could be either 30,000 planes or 70,000 planes. When they said that, they were completely laughed at. They said, "Oh, there's no way they're going to do 30,000." But come 1942, we have produced 100,000 planes, right? So no matter how good the quality of the data is, no matter how good the data of the modeling is, if the business impact and execution is of utmost value, right? So they probably had pretty good data. They probably had come up with a good model, but we said we're going to beat the expectations, and US productions, they rolled out everything that they can, and they worked 24 hours round the clock, and they generated twice the output that we wanted. So again, that's a case of data, uh, probably science statistical application, but it's relevant in the enterprise world, because you have to link your business strategy with the data strategy to the AI strategy. That is extremely important, right? Constantly, we have to keep that in mind. Um, and around the same time, another example of data analysis, I don't know if it is data science, but there are, I think it was the British planes that are going into the war and coming back with a bunch of holes, right? And then the Navy thought that, okay, we need to fix those holes so that we make those planes safer, and they kept fixing them, and they still kept on losing the planes, and they just didn't know why. And this is when Alexander Wall, he said, you guys are looking at the wrong way. You need to look at things which you don't see, which is basically the planes that are not returning. So you need to look for the planes where there are no bullet holes, right? So that's the survivorship bias. And these kind of um, data by nature doesn't have bias. It's our perception of it, how we look at it, is going to introduce the bias into it. So while the statistical rigor and those things are building up, people, how they perceive it and the different biases is they are trying to observe and qualify them and put them into rigor too. That's where we end up with good insights currently. That's going back maybe 70 years. But AI in general was defined probably in 1960s, the term, or maybe 55-ish. Data science as a term was defined in mid 80s, right? They just simply said that more scientific way of doing data analysis is data science. That's what the definition was. Um, but if you talk to any kind of accountants, whether they're cost accountants or chartered accountants or CPAs in US, anybody in the advisory services back then, um, they were applying these techniques of linear programming and those things all along, right? It's just that they were doing majority of it with hand, or with very little compute capabilities. So it didn't take off at the level that we want, but the compute capabilities kept on improving. So you saw applications like SPS, SAS, they were formed in 90s. They were serving the large statistical purposes of the companies, needs. And then we had an inflection point coming to the cloud, where you can tune up and down the storage that you want and compute that you want. I think that has really released the beast out. And they said, you know what, whatever we can do on one computer, we can do on 100 computers in a matter of an hour, and then we scale it back, right? So that truly, the ML capabilities have really enhanced the applications of data science in the enterprise world or any world out there. That brings us into the current times. today, it's enterprise AI or enterprise analytics teams. People think that whenever they say AI, they think it's all data science, right? But it's the teams comprise of, again, we go back to data quality. And in order to have good data quality, you need to have the foundations of good, data governance and quality initiatives. And you need to have good data engineers who can bring the data for you as quickly as possible. So you need to have data engineers in the team. And then you need to have data slash business analysts who can understand the business of data and data of the business both ways, and who can work with the data scientists and the visualization engineers to in order to be able to tell the story and also form opinions and models and things like that. So we need to have quality engineers, not make sure that we're building the products are at the highest quality. We need product managers in order to make sure that the constant relationship with the business and the technical people are maintained. And also, an important aspect of it is we need ML engineers in order to take a model that's built for consumption for maybe in one instance, or one server or one environment, ability to scale it to at a higher level, right? So today's teams, they comprise of all these people. It's not only data scientists. They form a very important part. But even then, the data scientists, in the absence of everybody to support them, they will end up doing all this work, right? And they might not be that inclined to do all that either. So that might, in order to, by giving them the appropriate support, we are empowering the data scientists to go and do what best, to get the best insights out of that. Um, so in CDW, instead of saying that we focus on AI, I mean, we focus on ML aspects of it, like what can we do, to in order to serve our company's needs. Basically, how to improve seller efficiency, like, save time for them, or help them in any kind of non-sales related routine tasks or repetitive tasks. We can um, automate that for them. Some levels of RPA and IPA. RPA is robotic process automation. IPA is intelligence process automation. Any kind of smart routing that we can do. Any kind of um, customer research products that we build, which has tenets of data analysis and also ML and AI into one place. These are the things that we do. We also do digital analytics, and in order to focus on better digital customer experience, right? So everything that we do is tied to our business strategy, right? And we work very closely with our data management team in order to make sure that the business strategy aligns with their data strategy. And then based on that, we devise our AI strategy and make sure all of them are working in tandem. I keep going back to that, but that's the only way that we can deliver the maximum value um, right now. Today, there is so much hype in ML and AI. You can probably build a toilet paper, and if you say it has ML in it, it will get $1 billion valuation. You know, smart paper, right? But I mean, jokes aside, that is the future, though, right? A company without a good strategy is basically leaving money on the table, right? Whether in the past or whether in the future, you know we are driven by, for lack of better word, greed, right? And that's a good thing, a desire to do things better, building better companies, or building better reservoirs, or all those things, right? So, and most of it is driven by FOMO, like fear of missing out, right? So whether we are building today or what we're going to build in future will be based on that, right? And the majority, maybe 50-50. Don't quote me on that, but some of them will be successful and some of them are not, right? It is very similar to the gold rush that California has seen it, but it has done great justice, to California. Look at that, it's a great economy. So similarly, companies, by keeping an eye on the hype cycle, but we still need to invest in AI strategies, right? And that means you need to invest in solid data strategy and also good business strategies. So around that, what's my take is that I cannot predict singularity and things like that. I'm not an expert on that, but maybe in 5 to 10 years time frame, obviously there will be a lot of consolidation that will happen in that space, right? Like a lot of people are coming up with boutique solutions using AI, right? So there will be a lot of consolidation, and primarily that will be driven by large scale ERPs and those companies and CRM companies and supply chain application companies. They will be bolstering their ML and AI capabilities to a grand scale, but their data quality will continue to suffer. Okay, like they're not going to magically be fixed. So companies like you, what you do is going to be very very important, because the quality of data that you provide is superb. That is going to help them easily embed the AI ML whatever they want within their application itself, right? So that is something I think that's happening, or that's going to happen even more in near future. um, Another one I'm thinking is specialized NLP packages, right? Like right now, if you go into the market, you can get like specialized NLP packages for, say, clinical information systems and that kind of stuff. But I think in future you can see specialized marketing NLP package, or sales, or customer success, or technology sector, selling in technology, all these things. There will be specialized packages, maybe legal. I'm sure if it's not there, legal will have their own NLP packages also. An extension of that would be advanced contract analytics, right? Basically, where you're saying, okay, this contract from this side and this contract from this side, they need to be make sure that they align. There can be solutions that will come in and look at those both documents together and say, hey, we are 90% good, or and this 10% we are not good, so we need to talk about it, or something like that. So there will be some advanced contract analytics that will come out of it. But let's take one step back, right? Why are we doing any kind of analytics in enterprise world, right? The role of analytics and great insights is to empower your workforce to make decisions, and that decision sometimes can be buying decisions and sometimes can be purchasing decisions. I mean selling decisions. These are the only two things that we do, right? Essentially. So on the other end, you always have a human, right? Two AI systems can be completely efficient, but you need two human beings to agree to do the trade, right? So I think the the idea is, the more advanced and more supportive and accurate data insight systems that are built, you are empowering your decision making to push one level down, another level down, another level down, so that people are more empowered, but at the same time they're protected by the system which is telling them that go ahead and make this call, right? So that's something that I think is going to happen. Another thing we are seeing is extreme automation. You will see automation everywhere, and I think it's going to continue. You will not only get pizza built by a robot, but pizza built by a robot and also delivered by a robot. That kind of things are going to happen. Um, but essentially though, like anybody, what do they want to do is three things, right? How to enhance their customer experience, right? Make it better, make it so seamless that they want to keep coming back to you. um, Improving your existing products or finding better products to build, right? Ideation and things like that. And also making strategic and informed decisions. Basically, people are talking about democratizing data. I'm talking about democratizing decisions, right? I think those kind of things, decision making, right? I think you will see more and more push into that. Um, you know, that's future.